This video is for Design and Communication Graphics PN 4025 for week 8. This week's lab is going to be dealing with oblique planes and lines, which is a continuation of sections of solids as well as tangential planes, and it also integrates information that we've covered in other topics all lumped into this one topic. Now what you'll find here is that you're going to need an advanced knowledge of a lot of the constructions that we've previously covered in labs and a deeper understanding for what was happening. So if we move on here, first of all we're going to be looking at oblique cutting plane. Now we've already looked at oblique cutting planes in our tangential planes in our sections of solids. Now we're going to be hitting them off again, and we're going to be integrating a construction that we talked about at the end of our lab that we talked about tangential planes, which is the construction of forming cones to represent the angle of that plane itself to identify basically points of contact. Now for this we're going to be using them to identify the placement of the plane that is actually cutting through the solid object itself. So if I move on here, I actually have a sample question that I cover completing the process, where I include the construction that I was talking about here on the right hand side to basically come to my finished solution. Now it's very important that you travel through this, see all the constructions at play and see what's happening and how they're being applied to come to the final answer. This is very much a higher level question, and even at that it's a tough higher level question. A one like this is the type of question that you could be asked in an exam situation, so it's important for you to get an understanding for the construction itself and what is actually happening. As well as that, I have the finished solution here. Now for the finished solution that I've provided, when you're completing a question like this, I would encourage you to take down more annotations, because a lot of the thought process was actually just expressed throughout the video by me, while for you, if you're not videoing yourselves completing the drawing, I would expect you to be completing a lot of annotations on the drawing talking about what is happening, not just basic labeling. Now I have the very basic of the basic labeling here done, pointing out, for example, your XY line, your first auxiliaries, X1 and Y1s, as well as your traces, and if it's an elevation, a plan, auxiliary elevation, or an auxiliary plan, or whatever you're actually doing. We kind of want you to go a bit deeper, put in a bit of thought process behind what you're doing, explanations, detailed notes if you think it's helpful. Now after that, what I want to be talking about is skewed lines, which is another thing that stems off from this topic. Skewed lines, as you can see here, is a type of line. You can see that we have parallel lines, intersecting lines, perpendicular lines, and then we have skew lines. Now the thing about skew lines is that they don't hold any relation to each other, so they're not going to be intersecting, they're not going to be parallel, and they're not going to be perpendicular. So they're two different lines traveling off in opposing directions. Now if we move on, skewed lines themselves is often asked in exam situations as well. Skewed lines can be integrated into actual applied graphics, where you'd be using this for, let's say, mining geometry. For example, you might have two boreholes traveling down through the surface of the earth. One of them might have a cave in. There might be people stuck below at the bottom of one of the boreholes. For them to have a rescue mission, it might be in their interest to find the shortest perpendicular or horizontal distance between these two boreholes, and to do that you would have to have an understanding for this topic to find that. So for this question here, I actually talk about how to find the shortest horizontal distance between the two skewed lines. As well as that, I talk about how you can complete a similar question that's asking to find the shortest perpendicular distance. Now I don't go into detail in how to find the shortest perpendicular distance. I'd expect you to open up the graphics book, have a look at the constructions, very similar to the one for the shortest horizontal distance, just a small bit of a change towards the end of it. As well as that, I have added in here, the complete drawing. Again, I've done some very, very basic labeling here. I would expect you, when you're drawing out the drawings, because you're not videoing yourselves and talking your way through the process, to put in detailed notes explaining what's happening and why you're looking from this angle, or even what position you're standing in when you're getting the auxiliary from that direction. This is all important stuff to take note of, and it's extremely helpful for proving that you have that deeper level understanding and that then you can explain that within the classroom. This is going to be your lab activity 1, directly related to the first example provided in this lab. After you watch the first example, I would straight away go and tackle this. If you're having issues with that, refer back to it. The same constructions are used to find the solution. Same thing with lab 2 here. Same type of question, just the lines have been moved into a different orientation, the 2 skewed lines. So if you follow the procedure, you'll have no problem finish it. Again, take note of the shortest perpendicular distance construction, not just the shortest horizontal distance. Even if you want to do this sheet out again in your own time and change horizontal distance to perpendicular distance and see if you can find that. It is going to be an important thing for you to know, as well as that if it comes up in the exam, that you will be able to answer that when the time comes. After this, just have a look at your checklist. You have 2 lab activities this week. You have no principle sheet because it's all related back to principles you've previously covered. It is important to like I was saying, to put detailed notes into them sheets, especially when you have this extra time this week to do so, because there is principles at play. Now, they might have been previously covered in other topics, but it's still important to identify them, because if you're asked to identify them within an exam situation, key principles, that you can do so. And just ensure that all elements are submitted to Solus by the end of week 8. Other than that, if you need additional help, you have my contact details here, as well as that some of the recommended books that you can look at that will help you work your way through these questions.